Hi, my name is Sergio Farragut, and I'm excited to take you through a demonstration of how easy it is to productionize data for real-time account takeover fraud detection using Tecton. A few data points regarding account takeover. Over 25% of people have experienced a compromised account. ATO attacks increased 42% year over year last year. Account takeover resulted in nearly $16 billion in losses in 2024. Fraud prevention teams face significant challenges in detecting account takeovers. New attack vectors appear often and increase in sophistication, but deploying countermeasures takes months. Account takeover occurs in real time, and yesterday's data isn't enough. High-volume real-time ATO detection uses heavyweight data infrastructure that is expensive to build, manage, and maintain. It's hard to achieve and maintain model accuracy, which reduces detection effectiveness and can increase false positives that directly affect your customer experience, which results in more financial loss and customer churn. I'm going to show you how companies like Coinbase and Plaid have successfully addressed these challenges by transforming their feature development workflow and infrastructure management using Tecton. This solution integrates Sagemaker with Tecton to provide a low-latency ATO detection mechanism that scales up to 100,000 requests per second. With each request, Tecton serves the feature vector, and Sagemaker runs inference to calculate ATO risk. Let's go ahead and test this from the notebook. I'm searching users here, and you can see the different responses. Notice the elapsed times. Every time I click, it retrieves features from Tecton, runs inference through Sagemaker endpoint, and processes the final logic to grant or deny access, all in milliseconds. This is the Tecton platform UI. While transaction fraud teams normally spend months building or adapting complex data pipelines to produce features, with Tecton I'll show you how easy it is to build and deploy pipelines like these that establish expected user behavior using batch processing on historic data like the fingerprints for user devices and normal login patterns, monitor recent user login attempts and account changes using stream processing, and combine them with current user activity and third-party signals to calculate ATO risk in real time. Many fraud teams need to build batch, streaming, and real-time transformations on different technology stacks, making it expensive and difficult to manage and maintain. Instead, with Tecton, you define features with a simple standardized code and have all the infrastructure managed for you automatically. Let me show you how data scientists work with Tecton in any notebook environment like this one to quickly experiment with new features and train models. Streaming features are critical for ATO detection because the events that expose fraud occur in real time. Features like the count of recent failed login attempts, device fingerprint data, or unexpected password resets must be up to date at the time of a new login attempt. Creating a streaming feature in Tecton is simple. You define a streaming source, and then you define the transformation where you simply add your desired features to a list. This example creates counts of login attempts, failures over different time windows, last minute, last 10 minutes, and last 24 hours. Each aggregate feature is defined by just selecting a name, an aggregate function, a column to aggregate on, and a time window. Any pre-aggregation cleanup and transformation can be done in the function body. Data scientists can test and tweak their feature ideas directly in the notebook before putting anything in production. Batch and real-time transformations are just as easy because they all use the same feature definition language. Tecton takes care of the rest. After feature definition, Tecton orchestrates the end-to-end data pipeline for you. At runtime, it connects to data sources, provisions compute resources as needed, and manages ongoing data maintenance for all your features. Tecton keeps training and serving data consistent because it uses the same feature transformation code to create and maintain historical offline features and online serving features. By using aggregate features, you engage in Tecton's aggregation engine. That has been designed to deal with any time window very efficiently. It automatically uses incremental partial aggregation that handles large data volumes using less compute and less storage, which lowers the cost while still serving fresh features in milliseconds. Like many other fraud detection situations, account takeover occurs in real time. At login time, calculations need to incorporate pre-calculated features with login request data and other internal or external APIs, and it all needs to be completed with extremely low latency. Given that Tecton centralizes feature pipelines, it makes it easy to integrate all of these sources. The various inputs are accessible by simply listing them in the sources parameter. Using the request data and previously calculated features, Tecton makes it easy to use Python to calculate derived features like these. So now, we're ready to use features in production. In Tecton, a feature service defines a set of features used for training and serving a model. You simply list the features you want to include. For training, you start with a set of labeled events, like these, where each login attempt is labeled to identify ATO attacks. The feature service API features for events, is used to retrieve feature values as of the time of each login attempt record. This training data is used in your favorite ML training environment to train a model. And online feature vectors are retrieved using a REST API, or like we see here, through the Tecton Client SDK, which connects to the REST API. I'll show you the final deployment process in a bit, but for that, let's add some new features first. Quickly evolving attack patterns means that ML teams need to iterate quickly on new feature design, model training, and deployment to production. Let me show you how fast this is with Tecton. ATO defenses often pull data from IP reputation services, device fingerprint providers, and credit bureaus for identity checks. We're going to use an IP Insights model we've previously trained to get a risk score for the IP address in real time, and we'll use it as a new feature that can then be used to train and deploy a new ATO detection model. Tecton provides access to external APIs in both real-time and batch feature views. Resource providers optimize security and deliver consistently fast data retrieval. The shared resource accesses the Sagemaker endpoint that serves the model. So now we can use it in a new real-time feature view. Access to the predictor is straightforward. It can be tested directly in the notebook. We also create a new feature service variant that incorporates the new feature view in addition to the features it was already using. Using a variant allows us to train and test a new model without disrupting the features being delivered to an existing one. Okay, so we've added a resource provider to access an external model, a real-time feature view, and a feature service. We tested the feature view, and we've added these Python files to the local feature repository. Let's put it in production. After feature experimentation and design are complete, many fraud teams take months moving to production. They must understand the features that data scientists have designed and then build the data pipelines that will produce them. In addition to the time it takes, it also tends to introduce discrepancies in how the features are calculated. With Tecton, things are much easier and quicker. As a data scientist using Tecton, you design and publish your tested transformations to a shared code repository that is jointly managed by the ML team to publish into production. This is normally integrated into a CI/CD pipeline with peer review. For this demo, we'll do it directly from the command line. Moving into production is simply one Tecton apply command. Tecton builds the complete data pipelines in a matter of seconds, immediately schedules new materialization and ongoing data maintenance jobs. Back in the Tecton UI, you can see the full data lineage, from raw data sources through transformations to feature serving endpoints. You can see that the new feature service incorporates all the previous features, plus the new real-time IP Insights features we just created. Data scientists can discover existing features and reuse them instead of reinventing the wheel. Operations teams can view and control job execution, monitor stream processing and serving performance, and manage users and their access permissions with role-based access controls. Since the new feature service is now live, we can test the feature retrieval directly. This feature service can also be used to create new training datasets and train a better ATO model. So to recap, I've shown you how with Tecton you can quickly experiment and design complex batch, streaming, and real-time features using Python and SQL. Easily put them in production, create training datasets that improve accuracy of your models, lower cost, and save tremendous amounts of time. It transforms months of engineering work into minutes of Python and SQL code. Our customers are seeing 80% faster feature deployment, 10 times more features in production, and zero infrastructure management. Data scientists and data engineers can experiment and deploy new features without waiting for infrastructure teams. So that's Tecton. It simplifies, centralizes, and standardizes feature engineering, and it productionizes everything from source data to feature serving automatically so your team can make better decisions faster.